And we're going to be looking, our first one we're going to start today is estimating a mean when sigma is known. So essentially, we're going to be looking at questions where you got a sample and you want to use that sample to estimate what the mean of the population is. And the first situation we're going to look at is how can you get a good estimate for the mean when you know the sigma, the standard deviation of the population. You know when you use this, it means population, right? So we're going to estimate the mean based on a sample, right? Now, not only are we going to do that, we are going to do it in such a way that we can actually give you an interval of values. Now, dead easy to do a mean. Don't I just find the mean of the sample and say, my sample mean was 42, so that's my estimate. But that's not enough information. You'd like to get an idea of roughly the ballpark from it. And what we do is we use the theory of the central limit theorem, which says that you've just picked one sample from the sampling distribution. You're not quite sure which sample it is. It could be a really good one in the middle, could be not so good one towards the outsides. And we can create, by using some cool piece of software that's in your calculator, we can create a, an interval called a confidence interval. So, a confidence interval is a range of values where we are confident, hence the name, the mean of the population. How to phrase this is there. Example. Suppose I collected a sample and I found out that I haven't told you how, but I've created a 90% confidence interval and the answer was 35 to 38. That's kind of what the answer is going to look like when we're finished. Right, so imagine I collected a sample because I was interested in the average age of Americans, and I got this interval here. Now, when I say I'm 90% confidence interval, that's what we call this interval. What I'm saying is that I'm 90% confident, 90% sure that the real mean of the population is somewhere in the range 35 to 38. Right, so I'm 90% confident that it's there. I'm also 10% confident it's somewhere else in the universe. It could be I was totally wrong, right? I just got a bad sample, right? Now, if you take another example, a 95% confidence interval might be 34 to 39. Why would you expect a 95% confidence interval to be bigger, to be wider than a 90% confidence interval? So can you imagine this was the line and there's 35 and any number all the way up to 38. But in this one, it's 34 all the way up to 39. Why would this interval be bigger if you want to be 95% confident that you've got the real answer? Does it make sense that it should be bigger?
Yeah, you're including more data values.
Right, you've got more places to be right in, right? Now, there are 3 standard confidence intervals. So imagine I did this last one and it ended up being 30, what's that, 4 and 43. So can you imagine in this case, it would be even bigger. I'm 99% confident that the average age of Americans is somewhere between 30 and 43, right? Now you can see that that's the biggest one. So a truism here is that if you want to be really confident, right, 99% sure that you've nailed the number that you're looking for, in this case, the average age of Americans, you have to have a really big interval based on that, right? And if you want to be 90% confident, then you've got one. Now, I'm putting this in, and I'm doing it under duress. But I have to do it because some of the questions involve it. This book uses an 80% confidence interval. Nobody I know in the scientific world ever uses an 80%. 90 is the first one, then it's 95 and 99. Occasionally, there's another one better than 99. Have you any guesses what that might be?
99.7.
Yes.
Oh, that would actually be a better answer, Zoe, than the one that they use. I would have probably went with that if I was inventing it. You were damn close to it. But they just go a slightly different route. It's 99.9%, which kind of makes sense. We know that 99.7 also makes sense, but they went that road. Now, when you want to do this one, isn't this where you're willing to accept a lot of numbers to be as certain as any human can be that somewhere in that lot of numbers is the guy you're looking for, right? There is major differences. Now, this one up here, can you imagine that if you did an 80% confidence interval, the interval will be tiny. And can you see this pattern, this truism? It goes up the way, right? So isn't there a kind of balance between how big you want your interval to be and how sure you want to be that you've got it right? This doesn't exist, by the way, but, oh, can I put this fella in as, what, a 28 and a 45, right? If I wanted to be 100%, in other words, I wanted to be guaranteed that I got the average age of Americans, right? Couldn't I say 0 to 500? Would you agree that the average age of Americans is probably somewhere between a newborn baby, which means everybody in America just got born today, which is not happening, right? Or somehow or other, we're all very bad at counting our age, and the average American is 500 years old. Would you agree that would be 100% correct and also 100% useless? It tells you nothing, right? So as you move up the food chain, the interval will get bigger. So you'll be more comfortable that you know you've got the right answer. The disadvantage is it's such a vaguely big answer that how much information do you really know? Well, I know it's somewhere between 50 and 5 million. Oh, thank you for nothing, right? So the normal going rate ones are these three here. And because the book does it, I'm adding the 80%. So how do we calculate those things? Well, there is a formula for it, which I'm going to show you. And then I'm going to show you that the calculator does it quite nicely. Right. The formula for calculating a confidence interval is the mean of the sample plus or minus the margin of error. E is called the margin of error. And this guy the margin of error is equal to this weird fella called Z star sigma over root n. And we all know that sigma is the standard deviation of the population. And who's this weird guy called Z star? Well, if you want a 90%, a 95, or a 99, or for that matter, an 80, this is who this guy is. For instance, he's the number 1.645 if you want a 90% confidence interval. And he's very often written as Z.645. 1.90. And if you want a Z.95, he's a 1.96. And if you want a Z.99, which is a 99, it's 2.575 or 2.58, depends on the textbook. So if you wanted to do this by hand, which is what this will be, and I'll take you through one question where I'm going to do it by hand, and then I'm going to show you how we get the calculator to do all of that hard work for us, because really that's how statisticians would do it, right? You wouldn't do everything, you know, with a button and a calculator, right? So
Those bottom two Zs supposed to be Z stars too?
Z star's the placeholder. Once you take and put a number down, they don't have Zs on them with a star.
Oh, okay. Okay.
So Z star means any one of these three numbers. But once you tell me what the number is, the star goes away.
Okay.
Right. So let's pretend for a minute, right, that I collected the average age and it ended up being 32. And I did this with a sample of 100 people. And let's suppose that in this question, sigma is known, and it's known to be 5. From only this information then, I would like to calculate, right? I would like to calculate, well, what do you want? I'm not doing 80s, we'll do 80s when the book asks us to. But 90, 95, or 99, which one of those three do you want me to do a confidence interval for?
90.
Pick a number.
95.
95. So we are going to do a 95% confidence interval. So it's X bar plus or minus the magic number sigma over that guy. Now, the mean is 32, plus or minus 1.96, times 5, divided by the square root of 100. It's not too onerous, but I mean, there is a fair amount of button pressing on these questions. And I get 32 plus or minus 0.98. 0.98 is that E guy. 0.98 is called the margin of error. That's its name. Now, if you take this guy and subtract this and this guy and add that, on one side you get 32.98, and in the other side you'll get 31.02. So I would make, very roughly, I would make a prediction based on my sample of 100 and the mean that I got from my sample of 32, that the average age of Americans, 95% confident, is somewhere between what, 31 and 33. That's pretty good, isn't it? For a relatively small amount of work. Feel good
Professor,
about
I
that?
have a question.
Yes.
So in the book, the Z star, I think it's like a Z with a subscript of C. Is it the same thing?
Yeah.
Okay.
So they're, what I'm calling Z star, they're calling ZC. Now C becomes 0.95 or whatever it happens to be in the question, right? So I guess C makes sense, confidence interval C, right? Different textbooks do things different ways, so it's not a bad idea to see different ways. Are you comfortable about how that was created?
No, I have a question actually.
Yes.
I'm sorry, I missed how you went from Z subscript 0.95 and made that 1.96.
Over here, there is a magic
Okay.
number that's
Oh, yeah.
always the same.
Mm.
So when you're doing a 95% confidence interval, you're always going to use this Z value, 0.95, and he is equal to 1.96. You see that 1.96 my finger is pointing at?
Mm-hmm. Where did you get it? Where did that number
Oh, this is magic. We tell you. Right? Now, if you want to know where did the magic come from, do you remember doing normal distributions? if you want to have 95% of your stuff in the middle, do you know the Z value that you use is, you would say 2, but if you want to be really nitpicky, it's 1.96. So 95% of the middle comes from 1.96. So that's where that magic value came from.
Is there a chart for these magic values?
No, there are only 3 of them, so you just memorize them by writing them down somewhere.
Okay.
We're going to, okay.
Is it just the 3 that you have on the right-hand side, the 1.64, the 196, and the 2.5?
There is an 80% one, but my brain cringes to writing that down. So you're just going to have to look at it and find out. I don't know anybody except this darn textbook. I wish I would have kicked out all the 80% questions, except there were not enough questions left. So I had to keep a few. But in a few seconds from now, I'm going to show you why you don't need to worry about even that, because that whole process that we've just done can be done on the calculator without you having to go through the steps. But I wanted to show you the feeling, right, of how it's done, so that you can kind of get an idea what the calculator's doing. It's just making your life a bit easier by doing everything for you. So let's kick out of this and where am I? Oh, basic. And this fella. Are you looking at a TI-84 emulator guy? Okay. So the question had a mean of 32, 100, and a sigma 5, and we are going to try, and I hope I remember where in the heck it is. We're going to go stats. We're going to go over to tests. So I'll do that slowly. Stat button. Scroll over to tests. And then you're going to go down here. And you're going to see, I believe it's, just double check that. Yeah. You're going to do a guy number 7 called Z interval. Now, when I hit this guy, he has got 2 choices here. The one that's flashing right now is data, and that's going to be for quite a few questions, because in quite a few of the questions, they don't tell you the mean. They tell you the numbers in your sample were 14, 7, 92, in which case you will use data and see in the list L1, that's where you'll put your numbers. Now, if I scroll over to stats and I hit that button, can you see it's now changed the menu? So I'm going to go through my menu. In this question, wasn't sigma known to be 5?
I'm sorry, can you I'm kind of lost.
Okay.
Which one am I supposed to push under?
Okay, from the beginning, hit stats button first. Right, we'll take it through slow.
Okay.
That way I can, if you go back and look at this video, you can pause and do it. Right, so we've done that. I'm now going to scroll over to the guy called tests. So 1, 2, I'm on tests.
Okay.
I'm now going to scroll down to choice number 7 called Z interval. I'm going to hit enter. You should be, if you've got an old calculator, you should be looking at this.
Yes.
Now.
Mine's popped up as with the 95% on the C level, but mine came up with 12.2 and 5 automatically in there instead of zeros.
That's just whatever the last data was. We're going to change it to whatever data this question requires. So we're going to have it on stats, because in this question, that's the way the information was given, right? I wasn't told the data, wasn't I? Just told that the mean of the sample was 32. So we're on stats. So you scroll down and you do sigma is 5. The mean in this story was 32. The number in this sample was 100. And then if I scroll down, do you see it has a confidence level? Right now it's 95, which is exactly what I want. But if I wanted a 99, wouldn't I just type in 0.99? If I wanted a 90, I type in 0.90. And begrudgingly, if I wanted an 80, I type in 0.80. So can you see it really doesn't matter about the magic numbers now, because the calculator is going to take care of that internally for you. So we got this guy, and now we're going to calculate. And I'm going to hit calculate, and fingers crossed everything's right. Boom. Do you see the 31.02 and the 32.98 that I gave you a few moments ago? Do you see that it did everything for you? As long as you know how to put the numbers that you need into your calculator, it will do everything for you. And wouldn't it be relatively easy to go back and do a 99% confidence interval if I wanted to, or one of those dreaded 80% if I really had to? Now, you can do it by the hand method, in which case you have to remember those magic numbers. I'm a fan of this because to me, and this is just less work, but it's doing essentially the same job. You agree it's the same answer, it's doing the same job, right? It's a bit like, well, what's the analogy? I know how to multiply 823 by 123, but wouldn't it be just easier to let my calculator do it? So I know how to do these questions by hand, right? We know how to do them by hand. I've showed you one. All that will change is the numbers that you use. But I prefer not to. I prefer to, get to the meat, which is what's the answer, right? What's it equal? So far, so good. Right, now let me return back to the whiteboard, and hopefully you'll still have fresh. Oh, I get chat. I get somebody got a question. Ah, you're welcome. Joshua just said thank you, everybody. Okay, so we just found this guy, didn't we? Now, sometimes you get asked a couple of other questions at the end of this process. Would you say that there's pretty strong evidence that the average age of Americans is at least less than 32? Sorry, 33. Would you agree it's evidence here in this interval that the average age of American is at least, 33 or less? Another way of interpreting that, wouldn't you say that the average age of American is probably 31 or more? Right. It's the same interval, I'm just kind of expressing it in slightly different formats. Then they might ask you one of these, A, B, C, D choice questions. Is it possible that the average age of American was actually 29? Right, the population, the average age of Americans is 29. Is it possible based on what we've just done? And the answer is yes. We are only 95% confident. Doesn't that mean there's a 5% chance we got it wrong? And 29 would be one of those 5%ers. If I did this 20 times, right? If I did different questions like this using a 95% confidence interval, if I did it 20 times, wouldn't one of those 20 times my interval be wrong, right? The real answer is somewhere totally different. You can't be 100% sure, not from a sample. You'll never be 100% sure. The best you can do is put a confidence level on how sure you are, right? If I would, nobody would do this except maybe this textbook in a bad day. If I said the 10% confidence level, and I gave you a number, right, an interval, and I said, I'm 10% sure it's in that interval, you probably wouldn't pay much attention to what I just said then, would you? Because 10% confident isn't that, hey, by the way, I'm a 90% chance I'm getting this wrong. I mean, nobody wants to base any kind of decision on a risk factor that is so bad. Now, if you wanted to be a gambler, isn't 95% a better number? You're going to win, i.e. get it right, a lot more times than you're going to get it wrong. That makes sense what I'm getting at. Now, another thing that people tend to put is, if the sample happens to be, in this case, 32, right? The mean was 32. A lot of people think that that somehow means that 32 is more likely than the 31.02 or the 32.98, right? They think because it's in the middle, it's more likely to be 32 than it is to be 32.1, right? Something like that. That's not the case. every single number in this interval is just as likely to be the real answer as any other. That just happened to be one sample. We know from experience, isn't it a miracle if that was bang on the middle? That was the population mean, right? That's a miracle, right? You know, it's more likely to be really close, which means any of these could also be true, right? So if they ask you a question like, is 32 more likely to be the answer than 32.5? Your answer will be no. They are all equally likely or equally unlikely.
Good question.
Yes.
On Thursday, we covered how to find a range that the mean might be in by just looking at by picking how many standard deviations are away from the mean for 95%, 99%. But so I was wondering what the difference between that is in the confidence interval.
Virtually identical, just some tweaking. If you do 2 standard deviations, which is a 95% confidence interval, it's a whole number approximation. It's 2. If you use a Z value of 1.96, you go 1.96 standard deviations away from the mean, and that is more precisely 95%.
Okay.
So it's a kind of more
Okay.
accurate version of the same thing, essentially.
Okay, that makes sense.
Right. So where am I going here? Oh, let's suppose that we do the second type of question, which is, I'm going to give you a set of data. Let's suppose that we took a sample of 5 things. So 5 isn't a great sample size, but it was 5.1, 4.9, 4.87, 5.2, and 5. So this would be a kind of rough and ready thing. Imagine there's a machine that puts potatoes into 5-pound bags. And, you know, potatoes don't go in exactly, right? You never get exactly 5, right? So the machine is designed to try its best, right? And these are the numbers that came out of a very small sample. And what you want to do is just check, is this machine working okay, right? Is it, on average, is it turning out about a 5-pound bag? You know, sometimes you're going to get 5.1 and sometimes you're going to get 4.8, but on average, it's going to do that. And let's suppose that we know sigma, because for this question to work, we have to assume that we know what sigma is equal to, right? So I'm going to say, let's assume that we know sigma is 1.5. Now, in this case, the sample size is tiny. I just did a 95%, didn't I? So let's do a, because I've picked it, let's do a 99% confidence interval based on this data. So if I was going to do it by hand, which I am, just to show you how you would do it by hand, and then I'm going to show you how you do it in the calculator, and then I'm going to try and sell the calculator way of doing it. Now, for 5 numbers, it's not a biggie, but can you imagine this is 15 or 50 numbers, and some of your data sets are, at least I think one of them is 30 numbers big. It could take a lot longer. So based on these numbers, can't I just calculate the mean, the good old-fashioned on a calculator, right? So I'm just going to go and I'm going to do that. It's going to be 5.1 add 4.9 add 4.87 add 5.2 add 5, and I get 25.07 divided by 5, and that ends up being 5.018. So far, so good. Now, for a 99% confidence interval, we're going to do the mean plus or minus the magic Z score for 99 times the standard deviation divided by the square root of the sample size n. So in this case, 5.018, give or take. Okay. Who has been good at memorizing digits or has notes in front of them? What's the magic z-score for 0.99? It's the same number for every question.
2.58.
2.58.
And two people were right on it. Yeah. Multiplied by 1.5, divided by the square root of 5, and we get 5.018, give or take. And so I'm going to go 2.58 times 1.5, and I'm going to divide it by the square root of 5, and I'm sad and frissing. You see, I didn't swear there, right? Did you all notice? I did not swear. I said
I'm proud of
sass and
you.
frassing. I was really good at that. True story. I've already mentioned to you, there's to 3 decimal places. I've already mentioned to you that I was brought up with a lot of sisters. And my mum and dad were totally different personalities. My mum was a wonderful woman. I don't think I ever heard my mum in her entire life swear. If I did, I have no recollection of it. My dad would swear at the drop of a hat. My dad was a coal miner, you know, rough and ready, tough as nails. If King Kong came into the street, my dad would want to fight him. I mean, that kind of personality. Didn't have a fear in the world. Swore like a trooper. And I picked my choice of words from my mum. So I got, you can go one way or the other, right? You can swear like a sailor, like my dad, or you could never swear. I don't swear, but I swear very rarely, like my mum. So I pick up my mum. My older brother, Billy, on the other hand, who indirectly did become a sailor, total side story, he swears like a trooper. So in the same family, when we get together, some people, those people who every second word sounds like a curse? Yeah, that's some of my family.
My grandma's like that.
Yeah, including, believe it or not, one of my sisters. And then the other side of the family is me and my brother and all the other sisters. And they say sass and frassen or something instead. I wonder why that's the case. Why your brain decides to choose one road than the other. I think swearing is very important. I use swearing for when I hit my thumb with a hammer or when I get really, really angry, because then it's a release. Right? But if you swear every second word, what do you do when you hit your thumb with a hammer? I guess you just swear a lot. I don't know. It doesn't have the same effect. So back to this guy.
Excuse me, Mr. Robertson.
Yeah.
Could you input that in the calculator for me again? Because I'm having a hard time with my square root button. On my
sure. I'm going to switch over to the main screen. Let me finish this off and then I shall do exactly what you said. So I'm going to take this number and subtract that and this number and add it. Remember, this is called the margin of error. So let's see what we got. We got 5.018. Take away 1.7.
Yep, got it.
Okay, thank you for telling me that. So that's 3.287. And on the other side, it's 6.749. Wow. This is a huge range, isn't it? If you wanted to know how well this machine is doing. In fact, based on this range, couldn't you really not tell if this machine was doing £5? Couldn't you be losing a lot of money because it's actually on average doing £6? You're selling it as if it was £5 a bag and really you're giving them 6. On the other hand, people wouldn't want to buy a £5 bag if they take it home and say, that doesn't feel like anything near £5, right? You're probably going to bring it back to shop and complain. What's the only real feature that I have any control over to try and, well, two features, but one important one, to narrow this interval so that I can actually tell if this machine is doing its job or not. What have I control over?
You could use a bigger sample size.
Yeah, couldn't I should maybe test 50 bags of potatoes? Can you imagine if I tested 50? Wouldn't this number now become the square root of 50? And if this number became the square root of 50, wouldn't the margin of error get smaller? And wouldn't that make my interval smaller? So the moral of that story is quite simple. Big samples help, right? Big samples give you more accurate answers. Big samples shrink your interval down so that at least you've got useful information. So what we're now going to do is that same question, but we're going to do it on the calculator. And I think one of the problems you might have discovered is that you need to do different stuff with this one. So I'm going to hit start. Oops, I'm going to make the thing on. I'm going to hit start. And the first thing I'm going to do is number one, which is edit. Because in this question, you have to put in the data. In this case, it's 5 numbers. So you're going to go 5.1 and enter, then 4.9 and enter, and then 4.87, and then 5.2, and then finally 5. Now, can you just imagine for a minute that this was 50 numbers? Do you want to do the mean by hand with 50 numbers? Can I kind of sell that putting it in, okay, it takes a bit of time, but would you agree it's a lot, if it's a large data set, it does save time eventually. Now what I'm going to do is I'm going to hit start again, and I'm going to go over to tests, just like we had before, right? And I'm going to go down to choice number 7. But now, instead of the stats choice, I'm going to move it over to the data choice. So if you've typed in numbers, you have to use the data menu. If you just are told the mean and standard deviation, right, as part of the question, then you move to the stat menu. Now, in this case, the sigma was 1.5. Now, here it says the list is L1. That's exactly what I want. That's where I put my data. So I'm going to keep that. Never change that. It's always 1. And then I'm going to change this to 0.95. And now I can hit calculate. And do you see, well, actually, maybe I can't calculate quite exactly, but 3.699 and 6.32. Why would that go wrong?
Now, would we have to like round that off, or that is the exact number that you would put in?
Well, I mean, if the book says to 2 decimal places, then you round your interval off to 2, and if it says 4, I guess you write all 4 decimals. Right, I've screwed up some. I think I know where I screwed up. The mean is 5.018, and they've got the mean as 5.014. I think that's part of my problem.
I noticed that you put for the confidence interval as 95 when you put it as 99.
Oh, well caught. Let me do that again then. I did. That's the major reason. That interval I just gave was correct if you wanted a 95, but we want a 99. There we go. Can you see it's much more the numbers I had? Right. So if you had a if you had a sample out there of say 80 numbers, can you imagine that it would be much better to do it this way than trying to do it by hand? But you know how to do it by hand if you're stuck. There is a lot of questions where that's essentially what's going to happen, right? You're going to be calculating 90% confidence intervals, and you're going to probably use the calculator. I suggest you do anyway, for every single one of them where it is possible. And let's return now to the white screen. I want you to imagine that I have, excuse me, a 95% confidence interval for a different story. And I'm going to make the numbers really easy for my brain. And we got really lucky. And the interval was 40 to 50. From only that information, I should be able to tell what the mean of the sample was. And I should be able to find the margin of error as well. So let's see if we can do that. If the range is 40 to 55, where do you think the mean is going to be of the sample?
45.
Would you agree it's the average of the limits, right? Halfway between 40 and 50. Agreed? Now, once you've got that guy, what's the margin of error? Well, it's going to be 45, right? Plus or minus something, right? And that's what we call the margin of error. Would you agree plus or minus 5?
Why 5?
Well, 45 take away 5 gets you this guy. 45 add 5 gets you this guy.
Okay, makes sense. Thank you.
Right. So, just as an one-off question, right, where you're not actually being asked to calculate a 95% confidence interval. They actually tell you one. But you can calculate what the mean of that sample would be in this story and what that guy would be. Suppose they went and gave you this interval, and then they went and said to you, if I made a 90% confidence interval, would the interval be larger, smaller, same size? Can't tell. So,
$1 monthly refunds for the month of March through June back to the card on file.
I'm not sure if that was a question or you were talking to someone. So here's the question. If you had a 95% confidence interval, which was this guy, and you then used the same information to create a 90% confidence interval, would the interval get larger? Would the interval get smaller? Would it stay the same? Or you can't tell? One of those.
Yes, smaller.
I have two choices. And that's the right one. Can you remember the connection between a confidence interval number and the interval that you get? A 90% confidence interval is quite small, right? Because you're only 90% sure you got the right answer. Right? Wouldn't a 95 be bigger and a 99 be bigger? Right? We talked about that in the beginning of the day, right? Right, if this represents a 95, won't you move in a little bit if you're willing to be only 90% confident? So the interval is smaller. I believe you call that in the physics world an inverse proportion relationship. It means as one thing gets bigger, doesn't the other thing get smaller? So as the confidence interval number here becomes larger, right? Oh, look, direct proportion. I got the numbers wrong, right? Direct proportion, right? As confidence interval gets larger, so does the interval that you would get from that. So if this gets smaller, that gets smaller. If this gets larger, the other gets larger. So far, so good? Right, so if I tell you, here's a sample, and I tell you X bar, and I tell you sigma, and I want a 90 or a 95 or a 99 or whatever the number is, do you feel comfortable that you could use your calculator to create a 95% confidence interval? Yes, no, maybe? Do you want me to do another one? Are we good?
Yes, can you do one more, please?
Sure. Just hold off a second. Here goes. Okay, I need some data to do this too. So what should we do? What should we do? What should we do?
I mean, you could do it. How many people have kids?
Well, how many kids you've got? Okay. Right. I don't have any. Me and my wife don't. Our dogs don't count. Marie, you don't have any kids yet, right? And you're not going to have them until you're in a stable relationship. Gotcha. Anybody else want to chuck in some zeros?
I'm a 0.
I'm a
Okay.
0.
I'm a 0.
I'm a 0.
I'm a 0.
0.
Oh God, no. This data is very, very lopsided, but we live with what we've got. Okay, I'm going to change the data supply for people who do have children, right? That way, my sample will be much smaller as well, and I can type in numbers. So, anybody got just one? Anybody got 2? Anybody got 3?
I have 3.
Yay. Anybody got 4?
I also have 3.
Oh,
Have
2
4.
more. 4, right?
4.
4. Any others?
I have 5.
We got 5. Anybody want to share any more?
I have 7.
Well done. Almost beat my mom.
Well done. I like that.
My mom always said after the first 3 kids, it really didn't matter. 5
Pretty much
kids,
so.
10 kids, after 3,
It's normal. It feels
it's
normal.
normal after
It
that.
feels
It
like
really
they were
doesn't matter.
like part of the family. Like you just brought them in. Like, hey, come live with us for a bit.
Pretty much so.
Yeah. Yeah, my mum, because she had babies for so long, that the first one in the family, my brother Billy, he got married, I think, when I was 4. I have a recollection of being at his wedding. So the first one get married, there's some of the others were getting born. So at any given moment in time, I don't think my mum actually had 10. A good family gossip for you here. I don't know, I'm homesick, so I'm sharing everything. One of my sisters is called Pearl. My sister Pearl I was very young at the time, but I knew something really weird was happening because there was a lot of family stress. My sister Pearl got married at 16, which is, you are allowed in Scotland to get married at 16. And no, she didn't get married because she was pregnant, which would be the most likely reason to get married at that age. She got married at 16 because she was pig-headed. And that wasn't half the battle. The fact is that she got married to someone who was 25. And my dad was not a happy guy, but it was what it is. So she got married. And my dad refused to have anything to do with him. Didn't want to see him, didn't go to the wedding, didn't do anything. Big family hullabaloo. And my sister Pearl started having a family, and a couple of years later. And once she got to the 3rd child, she had 7 altogether, my dad finally relented and would talk to him. He eventually was allowed to join the family because he was actually a good husband. And they've been married 50 years now. Now, that is not advice for any of you to go and marry a 25-year-old. That is, in fact, the total opposite, because I'm pretty sure that 99% of those don't end well, right? So pick somebody a little bit more age-appropriate, right? But just thought you'd say that. Yeah, I remember he had to sneak in when my dad wasn't in the house to visit my mum, because my mum would talk to him. Right? When my sister brought their kids and her husband to visit us, she always had to do it when my dad had left the house, so that he wouldn't there wouldn't be a big argument about it.
How many years apart were they?
About 9, I think that is. Yeah.
Me and my husband are 20 years apart.
Yeah.
Yeah.
But it's different when you get older. I mean, see,
Yeah.
when you're 60, somebody at 50, it don't seem so much, right?
Yeah, he's 60, I'm 40.
Yeah, so those age differences, as you get older, your percentage difference to your partner shrinks.
I think it's hilarious.
Okay, all right, now, as I've done my little thing, we're using this data here because it's easier to work with. And I guess if I was being really precise, wouldn't I use all those zeros? What in heck am I doing here? I picked the wrong one, sorry. Too busy talking and not doing my job. Here we go. Okay, so what I'm going to do is hit start, hit edit, and then I'm going to just get rid of all these guys. Okay, I can do this. 1, 2, 3. My brain says you gotta do what you gotta do, so I want the thing to be accurate. I think I got 10 zeros. We'll say it's 10, I think it was 10. And then we got a 3, then we got another 3, then we got a 4, then we got a 5, and then we got a 7. I guess I should be thinking about who the population is. In other words, who you're a sample of. I don't think you're a sample of all of America. Would you agree? You're not really that kind of population. I think you're a reasonable sample of OC students. Would that be a better population? So we're going to look at the average family size of an OC student, right? That's essentially what we're getting here. Right, so you get your data in, great. You hit start. Okay, tell me, which menu do I now go to?
Test.
Right. The more of these you do, the quicker it gets. Okay, which number choice do I do?
7.
Do I use data or stats for this question?
Data.
Right. Great. So I should be able to, oh, I need a standard deviation. Can we pretend that I knew it was 1.5, which is totally unrealistic, but can we pretend I knew it? You have to for the question. L1's good one. What kind of confidence interval do you want to get this time? Should we just bite the bullet and get that annoying 80 so I got it out of the way? So an 80% confidence interval, and then we'll hit calculate. And somewhere between 0.9, I'm rounding it off really badly, and 1.9. Okay. And with a mean of about 1.4. Okay. We are done.
Why are they giving you a sample standard deviation?
I think they just give you that as because they want to. It's not anything I'm actually going to use.
Okay.
Because they want to. I can't give you an explanation. I guess maybe you would like to know. The reason I might want to know that, I'm thinking about that. I said 1.4. I said 1.5, didn't I? Now, if this number was distinctly different, then I might be worried about my assumption on sigma being 1.5. And that's pushing it a lot. That's about the only reason I could want to know that in the context of this question. So just to finish off this question then, here's our interval. Would it be reasonable to assume that the average family size of an OC student was less than 2? And somewhere between 0.9 and 1.9 is the average, right? Now, I know you can get 0.9 of a kid, but you know what averages typically mean, right? About 1 up to 2, right? So somewhere in the range 1 to 2 children, right? Now, do we have 7? Yeah, but we have a lot of zeros, so they kind of balance each other Are we cool with that? Now, knowing sigma is very rare. Could you imagine? It's hard to imagine how you would even know sigma, right? The population standard deviation. Would you agree that in most real questions, you don't know sigma either? You don't know the population standard deviation. So let's look at estimating means. When sigma is unknown. Now, to do this, if you look at the textbook and you read it over, you're going to do a thing called the student t distribution, and you're going to do all sorts of things called degrees of freedom. But essentially, to answer these questions, what we're going to do is we're going to create the same kind of confidence intervals as we did before. But we're now going to do it without knowing sigma. So what does that formula look like? Well, it looks like X bar again, plus or minus the margin of error. It's going to be X bar plus or minus T star, the sample standard deviation, I'll call it SX, over the square root of n. Do you see there are two differences? Do you see the major difference is that I use the standard deviation of the sample, right? That guy. And then you've got this funny guy. He's not called Z, he's called T. And he's called the student T distribution, T value. And T will have a number like 0.90. It will have a number 0.95. And it would have a number 0.99, just like the Zs would have, right? But here's the problem, and this is why the calculator is going to work. If your sample size is, say, 50, there's a thing called degrees of freedom, and it's always the sample size minus 1, so this would be 49. Then what you have to do is you have to look up a table with lots of numbers. And you look up a table where degrees of freedom are 49. And you see these three magic numbers? They will be for 49. I'm making this up, so don't write this. Well, you can write it down, but remember, this isn't real. This is me just making up numbers because I don't want to have to go and find that table to look them up real. But can you imagine, this is 1.5, this is 1.9, and this is 2.3, right? And then if you had a sample of 500, there would be a guy called degrees of freedom 499, and you'd get different numbers. So the magic numbers keep changing depending on the sample size. So that's going to be a real pain in the butt, right? Because if you wanted to do it by hand, at the back of a textbook, or in your case, at the back of the ebook, there'll be a couple of pages with, along the top, degrees of freedom, and then 90, 95, 99, and what numbers you would use to replace this fella, right? And the second issue is, don't you now need to find the standard deviation of your sample? Right? Now, you put that whole package together, it's really very cumbersome, and it takes a long time to do it by hand. So wouldn't it be cool if the calculator would just do it all in one go? So when you know sigma, you could do it by hand, or you could do it by calculator, and it's up to you, I guess, what you feel like. But when you come to do student t distributions, you really do have to do it by calculator, right? So what we're going to do here is we're going to create some data, and we're going to find, I don't know, whatever confidence interval we want from that, right? So I'm just going to make up some data. This is a test out of 100, and it's a very small class. And I only took a sample of, well, it wouldn't be, let's say it's a really big class, and I only took a sample of 6 people. I would like to know a prediction on what the entire class's average would be, right? So the class is the population. Let's suppose it's a university class. This happened to me. When you go to university, in your first and your second year especially, classes are sometimes huge. Now, I went to a chemistry class with 250, at least 250 people in it. Do you know one of those step auditorium things? All wood, right? And the guy at the front, you almost needed binoculars to see him. That's what it was like. So can you imagine that's the class, right? And he just wanted to get a feel for what the average was, but he didn't want to do 250 numbers, right? So he randomly picked 5 people, and this is what he came up with. So we need to get this information. That's really all we've got. And what kind of confidence interval do you want? Give me a number. Because this will be part of the question.
95.
Okay, so we're going to find a 95% confidence interval. And let's pretend, before I even did this, that he wanted to know the answer to this question. Is there evidence that the mean of the whole class is greater than 40? Now, superficially, you might say, well, everybody in the sample was bigger than 40. So yeah, the mean of the whole class could be. But couldn't I have just been unlucky and picked the 6 best people in the class? Couldn't the other 244 of them been quite small scores, right? So there is that possibility, right? And we have to be aware that that is possible. So let's see if I can put that into the calculator. Now, if you can hang on a minute. You've never done this before, so maybe this question's unfair, but I think you should be able to maybe answer it as well. I'm hitting start. What do you think the first thing I'm going to have to do to get this confidence interval?
Go to tests?
Not yet. Before that. Maybe it's too obvious.
Oh, edit.
I got to put the data in, right? I got to put the numbers in, right? I mean, it doesn't know what to test if there's nothing to test with, right? So I'm going to go to number 1 edit, and I'm going to get rid of all your results. And now I'm going to type in the people that he chose. Okay, there was the 6 people, right? Now we're going to hit start. And since I already had the answer, I'm going to go over to test. Now, we have to scroll down here. Z interval is what you do when they tell you in the question, sigma is 5, sigma is 1.2, right? So if they tell you the population standard deviation, sigma equals a number, then you use number 7. On the other hand, if they don't, you use number 8. And you see it's called T interval for T distribution interval, right? So you got to make sure you pick the right one, or else you'll get an interval, but it won't be the correct one, right? So I'm going to hit enter. There we go. Now I can go data or stats. This is data, right? Data driven. Boom. We decided, I forgot what did, 95. Now, do you see that pretty much everything is done? I just needed to change this number. So when you're doing data, won't you probably leave everything alone and just change the confidence level? Because it's always going to be L1, right? And that's always going to be 1, and 95's the only change. And now when I hit calculate, I get everything. I get that the mean was 73, which is cool. And I got, I'm going to round this off, 56.6 to 89.4. And let's return to my white screen. Oh, so I'm 95% confident that the true average score in that that professor's big class is somewhere between 56.6 and 89.4. Is that interval evidence that the mean is greater than 40? Every single number here is bigger than 40, so yes. Is that evidence that the mean is bigger than 50?
No.
Are all those numbers bigger than 50?
Yes.
So, yes, it's evidence. The question was, is there evidence to prove that the average in that class was a number bigger than 50? And the answer is yes. If all the numbers are bigger than 50, right, it's a yes. Would it be true to say that he could say the average is bigger than 60? Not really evidence. Couldn't the answer be 56 and 57? It could be as high as 88 and 89. But if the number that you're testing is inside the interval, then you can't say for sure that the mean is bigger than 60. In fact, you can't really say for sure that it's 60. It's definitely possible, right? But couldn't it also be 57? So how you interpret, what else? Would you agree that there's evidence here that the average score is less than 90? Right, if all the numbers are less than 90, there's evidence it's less than 90. If all the numbers in the interval are bigger than 50, that's evidence that the mean is bigger than 50, right? So we're taking the package and saying everybody is bigger than 50, that's good evidence for me. So we now have two different sets of techniques here on estimating a mean. If you know the sigma, you're going to do that Z interval thing, right? And if you don't know sigma, you're going to do the T interval version. Very, very similar. Oh, and by the way, now I can tell you why that's there. Would you agree in this question, knowing the standard deviation is kind of helpful? Right, tells you something. Oh, I'm pointing at something you can't see. On the screen of my calculator, it told me the standard deviation of the sample was roughly 15.6. Are we good so far? Right. Now, if I had time, which I don't, I would give you a little sample of 5 numbers and ask you to do a 90% confidence interval and get you to hit buttons and do all that kind of thing. But time is our enemy right now. So I'm going to jump to the questions. Excuse me. I'm moving this around. Hopefully that won't do anything damaging. Can you see 7.1 estimating the mean sigma known, as it said? It should be sigma known, comma, sigma unknown, but I can only type so much in the heading. Right, so, oops, answers are really annoying, so let's take those out. Go on, go away. I made you go away, go away. It's not being my friend, go away. Whew, that was hard. Are you now looking at the questions without, you can't see them at all now. Have I totally killed that? Why are you smiling? Are you getting pleasure from my pain?
There's a line of blue.
Okay. There's only there. Are you now back to a clean version with the questions on it? That's kind of where we are, right? So here is a set of data. You can read about that if you want. Use your calculator with mean and standard deviation keys to find this fella. Oh, that one shouldn't be there. Darn it. Okay, I'll make sure I get rid of one. I didn't realize question 1 had go to the back of the book and find that magic t-score, right? So back to this one. There we go. Here is a set of data, which is the one that we should have started on. And we're going to look at the true ring dating method and for an archaeological excavation site and assume that population X values are approximately normal, right? Which is what these guys here are. And use the calculator mean and standard deviation keys. Now, if you go way back, can you remember to get those two guys? Can I tell you that you get them in that one menu anyway, so you don't need to do it separately? Because that will be told in the final pictures, right? The calculator has that number. And won't that also be in the thing? And then 90% confidence limit. So based on this data, can you see that you're going to use the t-interval? How do I know that question 2 is a t-interval and not a z-interval? Because they look very similar when you do them.
Because you don't have the standard deviation.
Right. If you don't see sigma equals 2 or sigma equals 10, you're going to do a t-interval, right? So if we had time, I'd do that. Can you imagine I type that all in, and this is 1200, and this is 42, and this is 1100 to 1300. That would be your final answer. So lower limit means a small number, right? Comma, bigger limit, upper limit is the second number. So instead of you putting the answer like this, you're putting them as 2 separate numbers. But yeah, you can handle that. Agreed? Now, what you're going to notice, I hope, is how similar these questions end up looking. Now, here is some data to do with how much does a sleeping bag cost. So someone collected data on the prices of various sleeping bags, and 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of them, right? Would you agree that's a t-interval because there's no mention of sigma? And X bar, standard deviation, upper and lower limit, call it good. Do you see all they did here was change the story? This is the price. So when you're finished, you're going to say the average price of a sleeping bag is 92 to 105, right? You're going to get that as your limits. And this one is going to be based on a 90% confidence interval. So we're 90% sure that the average, the typical cost of a sleeping bag is this number. That makes sense? Right. I think I'm going to have to do one. I'm picking this one.
Well, on mine, when I'm looking at the homework, it says something about a percentage of temperature.
Which question?
Which number was I just looking at? I scrolled down trying to catch up with you, and it was number, oh, where did you go? Oh, number 5.
I don't have that question. Oh, it's temperatures.
Yes.
These numbers aren't percentages, they're just temperatures. So that's 120 degrees and that's 120. It's just a number. They could have taken off the degrees Fahrenheit if it distracts you.
Okay.
So it's just a number. And these are horrible decimals. These are temperatures, right? I'm going to do the line one because it looks to me doable, right? It's not that onerous. So how much do wild mountain lions weigh? Adult wild mountain lions, 18 months or older, captured and released for the first time in the San Andreas Mountains, gave the following weights. So we've got a big mixture of weights here. I don't know why. Fat mountain lions and skinny mountain lions, I don't know. So, I'll shoot in space. Has anybody got those numbers in front of them, because I can only see one thing at a time the way this works, and I'm about to do my calculator. If somebody's got those numbers, great. Otherwise, I'm going to write them down and then go to the calculator.
I have.
Lee, well, right. You know that they vary them from questions, so I'm just going to pick Lee's numbers, and yours probably will be different.
Okay, mine says 72.
Oh, hold it. Are we looking at the calculator?
Yes.
Okay, so I'll get in. I'll do my edit. Give me a few seconds just to. Okay, I'm going to show you a really dangerous thing. Really dangerous. If you don't want to delete a whole load of numbers by hitting delete and delete until you get bored, imagine there's 30 numbers, that might get a bit annoying. If you scroll up to L1 and you hit the clear button and you hit enter, it'll do it in one go. Now, why is that very, very dangerous? If you hit the delete button, you will delete L1, and that's not good, because then it screws up how the calculator is going to interpret the data. So maybe I shouldn't have told you that then. Now that I've thought about it. Clear is fine, right? But don't do anything else. Okay, so give me your numbers. What you got?
I got 72, 100, 131, 125, 60, and 64.
Okay, unconnected to the story, can we pretend here that what you've got are males and female mountain lions? And I'm going to assume, because I know nothing about mountain lions, but I'm going to assume that the males are the 3 big weights and the females are the 3 lightweights. Do you know, if you were doing this as part of a study, I think it would make more sense to have average weight of a female mountain lion and the average weight of a male mountain lion. Do you think you would that would be more useful data? Because sometimes if you know what the average weight is and you go out there and you're looking at the health of mountain lions, one of the measurements is its weight. So if you know an average male should weigh 120 and you go out there and you dart them because you have to tranquilize them to get them, which is probably not a good thing, but I mean, they're pretty good at not killing them, right? So you get them and you weigh them. If you weigh a number of your mountain lions and you find out that instead of being 120, they're averaging out at, say, 100 pounds, wouldn't that be indication that the mountain lions are under food stress? They ain't got enough whatever they eat to eat. Now, that can be caused by, it's a bad summer and there's not enough baby goats or whatever mountain lions eat. It could be too many mountain lions in one area, right? Overpopulation can cause that as well. But it's useful to know. And I think that's what my brain is telling me, that maybe it's female mountain lions that are bigger. I don't really care which it is, but it probably is 2 different groups there. So that question kind of bugs me because of they could have done a better job, right? Yes. Now I'm moving over to tests and I'm choosing. Well, I know it's number 8, so if you do it often enough, can't you just remember the number and it saves you scrolling? So it's number 8. The data is good. L1 is good. I believe this question is, oh God, no. What percentage? I think I've got it on my screen now.
75.
If I'm annoyed at 80%, can you imagine how grating this is? Only because we need the answer, right? That's the only reason I'm doing this. Calculate. Can you now see that the average mountain lion is somewhere in the range of 75 to 109? I'm doing very crude rounding off. The nearest whole number is 75 and 109, and that the average is 92. And that the standard deviation in this sample is about 31. So in this question, now I'm going to return back to that guy. what I would do here is, what do they want? 4 decimal places. So, well, that's not going to work because I only have 3 in front of me. Oh, wait a minute. No. The answer was 92, or 92.0000. It was exactly 92. And the standard deviation is 31.2474. And the lower limit to 1 decimal place is 75.4. And the upper limit is 108.6. And that's pretty much the end of that question. Do you feel comfortable about how you're going to do this branch of questions? There's going to be a story about how much sleeping bags cost, the average height of a giraffe, the average weight of a mountain lion, the temperatures in a place over July. There'll be a story attached to your data, but won't it boil down to using your calculator and coming up with the interval? Do you feel comfortable? Right. Can you see question 7 is to do with how much does it cost to start your own business? So that 99 means 99,000. So I guess if you're young enough and have got good credit, and you probably need to have some of your own money, banks aren't going to just give you the full loan. But if you say, I'll put 20,000 and they'll give me the rest as a loan, you can get a business loan to buy a franchise. And evidently there's a factory called the Mountain Chocolate Factory. Never heard of it. Oh, actually, it's called the Rocky Mountain Chocolate Factory. Anybody heard of it? It sounds to me the kind of place you'd have in a tourist place, you know, where cruise ships come off and you have special, you know, specialty chocolates, right? And what's the other choice? Fudge Company.
Hershey has a big giant company and an amusement park over the East Coast.
Is it something like the Fudge Company or the Candy Express or Caramel Corner? What would we call that?
Yes, Hershey makes like all the chocolate and all the hot cocoa and stuff. And then they have like a little roller coaster that you can ride through the factory and it smells like chocolate the whole way.
Now, for some people, they're drooling right now. I do like chocolate, but I'm not a sweet person, so no. But I tell you a cool place to go if you drink alcohol. 2 places to go. In Scotland, you can go around a whiskey distillery and they show you where they make whiskey. And that place smells of whiskey everywhere. And the other place is go to Dublin and you can go to the Guinness factory and you can actually see Guinness being made. So I guess you can tell where my interests lie. So if we were going somewhere, my wife was going to go to the chocolate factory, which I bet you she would. She'd love that. I'll say, I'm going to have a look around the whiskey factory instead. Not that I suspect they're in the same building. But, oh, I got to tell you a joke now. Sorry about that. It came into my head. You ready? It's a sad story, you know, Scottish jokes. Somebody dies. Right. Well, there were 3 people worked in a distillery and they were working on the big vat, a huge open vat where the whiskey was. And there was 3 of them, 2 Englishmen and a Scotsman. And they fell in. The scaffolding broke and they fell in. And the 2 Englishmen lived, but the Scottish guy died. And so the manager of the factory phones up and says, some really bad news for you. And she said, what happened? Said, your husband died in an accident in the distillery. She said, what happened? He said, he fell into a vat of whiskey. And she said, I hope he didn't suffer. How long did it take him to die? And he said, 5 hours. And she said, 5 hours? He said, well, it would have been quicker, but he climbed out twice to go to the bathroom. Oh, come on, Scottish people would find that hilarious.
I didn't get it.
he liked whiskey that much, he went out to the bathroom twice and went back in on his own accord. Jenny, did you get that joke?
Yeah, I got it. That was a good one.
Kelsey's clapping. Marie obviously doesn't drink whiskey. Leah's got a thumbs up. Some of the rest of you, not all jokes work for every person, so I understand that. Okay. I've forgotten where we are, but that's me. Are we comfortable? Can I just go through some of these guys? Are you happy about the process of getting upper and lower limits? The vast majority of these questions seem to be working on the principle that you're going to use the T interval, at least the ones I see. Now, this is a question where there's a C part to it. So if we had time, I'd do the numbers. Over the past several months, an adult patient had been treated for severe muscle spasms. And this condition is associated to do with low calcium levels. So if your calcium's low, I think, don't you get that with potassium levels being low as well? Yeah, so this case, if the average total calcium is below 6. So this patient here gave the following levels. So he was measured over, consecutive days or weeks, right? And this is his calcium levels, from his blood tests. And we're going to, you imagine calculating the mean and the standard deviation and the upper and lower. Won't all that be done inside the T interval? Can I pretend that I know the answer? And can I pretend that the answer ends up being 8 to 14, just for argument's sake, right? So you can imagine the lower limit was 8 and the upper limit ended up being 14. Based on these results, do you think this patient has calcium deficiency? Well, you have to have a level below 6. Does his average level look like it's going to be below 6?
No.
No. Would you agree his average is good? So now, I don't know the full story. Maybe he's been treated and that's the result, and now he's okay, he shouldn't be getting spasms. Or, if he's not being treated and these are his normal numbers, then it looks like it's not a lack of calcium that's causing his muscle spasms. Maybe they should have tested potassium. Maybe they should be looking at motor neural things, right? Is there something wrong with his nervous, some diseases affect your nervous system, right? They don't react the way you should do. I think, doesn't multiple sclerosis do that to you? It basically buggers up with your signals in your muscles. I think it does anyway. So can you imagine, you'd cross that off your list, right? A doctor's trying to find out what's causing these spasms. Well, it ain't your calcium, because it has to be below 6 typically before that would be the cause, right? We'll check your potassium. Okay, it ain't your potassium. We'll check this. It ain't this. Some of you, unfortunately, you get something wrong with yourself, and doesn't it seem to take forever for the doctor to finally figure out what caused it? But normally what they do is they go through the most obvious things first, right? Yeah, is it this? Is it A? Is it B? Is it C? And then if they don't work, then it gets a little bit harder, doesn't it? The detective work of what's causing whatever your issue is. I think sometimes they probably still do it, at least they do it on the TV. I'm not a doctor. Don't they look up books that you tell, it'll be online now, where you put in symptoms and someone goes and, well, I had a patient, they put it out there, I had a patient with the exact same symptoms and this is the cause. And then the doctor says, oh, I'll see if my patient has that same cause, right? And that's typically true when someone comes up with those, do you know those really weird cancers, really rare? Where you might only see one in your entire medical career, and nothing fits, right? It ain't any of the normal things that you're looking for, and you're trying to figure out what it is, and you go online and you find 5 Americans a year have this very rare cancer. You can't expect a doctor, a cancer doctor, to memorize every possible cancer in the universe. I mean, there's probably thousands of the bloody things, right? And some of them are quite rare. I'm sure it's easy to test for lung cancer, right? When that show up in an X-ray pretty quickly. But, you know, I'm trying to make one up. Lymph node cancer, if there is such a cancer, probably is. Wouldn't that be a hard one to know? So, as we drift, but medical people, you all like that stuff, don't you? What happens here? Right, so we're back to square one. Good grief. Question 10. Good luck. You need a calculator. Agreed? There is no way you're going to do, I mean, okay, it's boring. Don't you have to type all the numbers in?
I was going to ask that question, like, do you have to type all those numbers?
Yeah, you have to type all the numbers in. So trust me, from a person who never makes mistakes, be careful. Right? Just be careful.
Yeah, right, and just type them in any way, like any order. It don't matter.
Oh, it don't matter the order. I don't know. Some of it, because I have a difficulty scanning, I normally type things in columns because I don't scan badly with columns. But if I try and do rows, what I end up doing is I stop here, then I continue from there, you know, and I miss a whole load of numbers and it's not fun. Whereas when I do them at columns at a time, I'm more accurate, but that's me. And then there's whole loads of questions based on your interval. It's a good question. I mean, it is fun. There is a couple of things that I haven't mentioned. They're really just what needs to be true before you can do any of this. Typically, what needs to be true is that you should have a sample bigger than 30, right? If you don't know the standard deviation. So I've broken the rules a little bit. If the sample, and you don't know the standard deviation, you need a sample size greater than or equal to 30 before you should do the test. Secondly, if you know that the population is normal, then you do not need to worry about sample size. You can do it with 5 people if you felt like. And there's little tweaks that are going to happen based on that, but that's basically the major rules. Back to standard question with a couple of choices at the end based on your interval. So depends on the question here. Standard question based on the interval. And that is the end of that section. Do you see it's really, for the most part, I'll kill number 1 that I should have put in. There are going to be 11 questions, so number 1's going to disappear. And they're pretty much the same question, aren't they? Plug into your calculator, do your thing. Okay, so I'm now going to leave that one. And at least get an intro to the next section. Oh, I've got some chat. Anybody got that? Okay, someone's commenting on the chocolate.
I just have a quick question on Z intervals.
Yes.
In the example in which you took data of how many kids each person had.
Yes.
And then to do a Z interval, you had to enter sigma, and I know you guessed it, 1.5.
Yes.
But I guess how were you able to enter sigma if it was a sample, not a population?
It's a sample from a population that I know the sigma value for.
Oh, okay.
Which is really realistically impossible.
Okay.
If I knew what sigma was for a population, if you think about it, isn't the only way I would know that is if I knew everybody in the population and I calculated it. And if I knew everybody in the population, why am I bothering doing a sample? It's a kind of silly question, right? So realistically, you would probably never know sigma, which is why it's so rare to get that version of the question, right? But it is possible, right? Most of the time, you don't know sigma, right? So you should really go T interval. If it's normally distributed, you could get away with a Z interval because it's normal, but I would do a T. Don't know what this book does, but I would always do a T in all those questions. If by any chance you do a question and the T interval doesn't work, well, you go through the same thing and do data and do a Z interval instead, and that'll probably work. Because this guy's got some weird concepts. 75% and 80% confidence intervals, to name but a few. Weird histogram intervals. Yeah. So I try and I've lost the darn thing. Have I closed that off? I bet you I have. Okay, class view. Hold on a second. Okay. The good news is that you already know how to do 7-2, because 7-2 is estimating mean when sigma is unknown. And for some reason, I think it's Tired Monday. Do you see the one I showed you all the way through? The one we just finished looking at? That's actually 7-2. And I labeled it 7-1. So what would 7-1 look like? 7-1 would be the ones where you'd be told sigma was 5. And it's the same darn questions, right? So I'll make one up, and then I'll make sure that I find the real 7-1 and put it on, right? Because what I did is I put 7-1 and called it 7-2, and then I put 7-2 and called it 7-2, so that was weird. So for 7-1 then, suppose you had...
Can we see your white screen?
Yeah, that would be a good idea, wouldn't it? I'm just getting kind of annoyed with myself. Can you imagine that you know 5 numbers and that sigma is 10? Right. Now, won't that go into my calculator as the Z interval one? And I have some data, and I have that guy, and we can do that. So I'm going to do this fella on my calculator, and here goes. So suppose you were told the ages of some children in a church group, right? A church club. And there were 3, I don't know how a 3-year-old got in, but he got in anyway, right? 3, 4, 6, 11, and 12. Now that's a sample of all the children in this church group. And we'd like to know what the average age of those children are, right? So we want to estimate X bar based on that. So I'm going to go into Start. I'm going to go to Edit. And I'm going to use the dangerous clear button. And I'm going to put in the ages of those children. There's a 3, there's a 4, there's a 6, there's an 11, and finally there's a 12-year-old. And now once the data is in, I'm going to hit the Start button. I'm going to go over to Tests. And which number do you use if you know sigma?
7.
Number 7. And we got our interval, and we're going to use data, right? And I know sigma is 10. And then let's say I want a 90% confidence interval. And that should be it. And negative 0.156 to 14.6. Okay, that is a 90% confidence interval. Okay, let's see how to interpret that in real terms. The reason that this interval is so massive is that, would you agree, 5 data points is not very a big sample, right? 50 kids would be better than 5. So that's the reason it's so huge. Secondly, common sense tells me that sometimes you adjust the interval to take into account context. I'm assuming that brand new babies are allowed to come to this church thing. God, I doubt it, but well, I'll assume that it is. Do you see that negative doesn't make any sense in the context of this question? So basically, babies up to 14.6-year-olds, somewhere in that range is the average age of kids at this church club. The mean is about 7.2, which is pretty much right in the middle there, as we did expect. Are we cool with that question? Give me a 90% confidence interval for the average age of a child at this church club. And the answer is somewhere between a baby and 14.6. And the mean of the sample is 7.2, but that is no better a guess than 14, right? The average age could be 14, right? And I just got unlucky and got a lot of young kids, right? Could be as young as 5 years old, right? Or 4 years old, right? And I just got unlucky and got a couple of older ones, right? Anything is possible. But it will be in this range, and I am 90% confident that it's in this range.
Did you say there's a reason why you got a negative number for the lower limit?
No, it's just numerical.
Okay.
That's the way it came out. But I'm going to change it to 0 because of context. You can't be negative. Well, I guess a pregnant mum could be in the club, so no, let's not go there. Negatives aren't allowed. End of story. We're done. Now, if these were temperatures, you know, during some winter days in the North Pole, couldn't negatives be totally acceptable as a context there? Right. Not all negatives are impossible. Depends on temperatures, it's okay. Heights, it's not. Do you know negatives could be okay with money? Didn't that just mean you've got an overdraft in the bank? Negatives could happen. Negatives don't happen with ages, right? So whatever the data is, you can tweak it. Now, the second version of that question would look something like this. You've already calculated the mean age of OC students in your sample, and the average came out as 30, right? And it came from a sample of 1,000, so that's a big sample. That's what Gallup poll does, right? They do about 1,020 odds, right? That's their usual going rate. So I expect really good data from here. And let's assume that sigma is 20, right? We know that it's 20. So in this question, we are going to get a 99% confidence interval, because that's what the VAST is for. So you're going to be told sigma in these questions, right? So sigma is known. And when sigma is known, right, it's number 7, right? That's the guy we're going to use. So I'm going to return back to our calculator.
And just so that I'm aware, if Z interval is not present, or when the sigma is not present, you use a T interval?
Yes.
Okay.
If you don't know sigma, because they don't tell you, you're on 7.2 and you're going to be using T intervals. And if they do tell you sigma in the question, sigma's 10, sigma's 20, then you'll be in 7.1, because that's where those questions will lie. Once I darn find the thing and put it online for you, right? That's where that's going to lie. And you're going to use the Z interval in those questions, right? So if I know sigma, Z interval. If I don't know sigma, T interval. that kind of make sense, that sentence? Right, let's look at this fella. I'm going to go straight into the tests, because in this question, we're not going to use data. Aren't we going to use statistics, right? In this question, let's see what we get. Sigma was 20, because they told me that. Oops. Did you notice I didn't hit enter, right? Now I'll go back into it. Sigma is 20. The mean was 30. The sample size was huge. It's 1,000. I'm about to do this interval. I can make a prediction here. This interval is going to be really tight, right? The start and finish number are almost going to be on top of each other. How do I know that's going to happen, even though I haven't done anything yet to check the answer? How do I know this confidence interval is going to be tiny?
Because the number is 1,000.
Yeah. A huge sample size is going to make confidence intervals shrink down to quite tight numbers, because it's going to be accurate, right? 1,000 people pretty much takes away a lot of the variation. Now, I'm looking for a 99, so there we go. And now I should get an interval. And somewhere between 28.4 up to 31.7. Yeah. Right. The average age of Americans, if this data, if my sample was correct, is what? Somewhere between 28 and 32. Right, with bang in the middle 30, right? Have you noticed that a lot of the intervals we've had before has been like 15 to 74, right? They're really big. And that was caused by small sample sizes. Now, this is the building block of a huge number of practical statistical experiments and analysis. When people go out there and they do a clinical trial, for instance, very often what you do is you collect data on your 200 patients that get the drug and the 200 patients who either get a placebo or they get the other drug, right? And when you find the average benefit in each group, right? An interval of what the typical effect would be. And don't you want your drug to be bigger than the other guy's drug, if big means better, right? So if you were looking at a drug that increased your potassium level, wouldn't you want the experimental group's average to be higher than the other group's average, right? Because your drug's meant to do better. And if you want it to be a blood pressure reducing pill, wouldn't you want your interval now to be full of smaller numbers than the other guys? Because that means on average, you've reduced the blood pressure. Any